In 1867, India was building one of the largest railway networks on the planet, but every single steel rail, beam, and bolt had to be imported from Britain. The British government dictated the terms, controlled the prices, and effectively drained the subcontinent's wealth to build its own infrastructure. India had no sovereign industrial capacity of its own. A 28-year-old Indian businessman named Jamsetji Tata understood exactly what that dependency meant. While attending a lecture in Manchester, he absorbed a promise that would drive the rest of his life. The nation that controls iron controls gold. Without domestic steel, India could never build its own bridges, buildings, or economic independence. To see the difficulty of this ambition, we have to look at this map of the Indian subcontinent. You need massive iron ore deposits, coal to burn, limestone to purify the molten metal, and immense volumes of running water, all within a close geographic radius. After 3 years of scouring the country, Tata's survey team found these 4 elements overlapping in only one place, a small area on the Chota Nagpur Plateau. The location was a village called Sakchi. It offered perfect raw materials, but absolutely nothing else. It was a dense, hostile jungle, completely devoid of roads, bridges, or basic infrastructure. Bears and elephants regularly roamed through the area where the survey team set up their camp. Jamsetji Tata realized that extracting the ore was only half the problem. Operating heavy machinery in a total vacuum meant building a factory and a fully functioning civilization simultaneously, from the dirt up. By 1908, construction began, creating a massive logistical bottleneck. Heavy structural steel and machinery were arriving by ship from America and Britain. With no internal roads to the site, workers dragged these massive industrial components through the mud, using bullock carts, raw manpower, and local elephants. While thousands of laborers carved out the physical foundation for the blast furnaces, American engineers Julian Kennedy and Solon were designing the social software of the site. They were tasked with planning the housing, hospitals, and streets that would sustain the workforce. This top-down view shows their initial solution. Kennedy and Solon deployed a classic American gridiron layout. They sliced through the jungle with rigid 90-degree lines, dividing the terrain into distinct zones for the steelworks and parallel blocks for worker housing. The effort climaxed in February 1912. The Sakchi plant poured its first commercial steel ingot. A British official had previously mocked the project, claiming he would personally eat every ounce of steel an Indian could produce. Instead, Tata's engineers proved that a domestic, integrated steel operation was entirely viable. But that initial victory created an immediate crisis. The demand for the new steel drew workers from across the country. The population spiked so quickly that the rigid American grid completely fractured, leaving the new settlement dangerously close to collapse. World War I accelerated the crisis. The British government required massive volumes of rails and beams for military campaigns across Africa and the Middle East. As the sole major supplier in the region, Sakchi's production went into overdrive, and its population exploded to 50,000 residents by 1918. In 1919, the British Viceroy renamed the settlement Jamshedpur in honor of Jamsetji Tata. But beneath the new name, the town lacked proper sanitation and drainage. Without immediate intervention, the dense overcrowding threatened to turn Jamshedpur into a disease-ridden slum. To fix this, Tata hired sanitary engineer F.C. Temple. Temple surveyed the broken grid and discarded the American model entirely. Instead of forcing straight lines onto rough terrain, he decided to map the city directly to the natural geography of the plateau. This topographic map reveals Temple's contour-adapted concept. New street networks curve parallel to the natural slopes. This elevation created a gravity-based drainage system, where wastewater flows naturally down the hills into intercepting edge sewers, keeping industrial pollution entirely out of local rivers. Temple's design established a precedent. Protecting the local environment and ensuring clean living conditions for workers proved to be a strict engineering requirement. Without baseline sanitation, a heavy industrial workforce simply could not scale. World War II drove a second massive demand spike. The plant ran 24 hours a day to supply Allied forces, becoming such a critical asset that the company installed bomb shelters and smokescreen boilers to protect it from Axis airstrikes. By 1944, the city faced a new urban threat. The sheer volume of industrial transport required to maintain wartime production meant massive, heavy trucks were tearing directly through expanding residential neighborhoods, creating a deadly hazard for the workers. This abstract layout illustrates the solution by German architect Otto Königsberger, a strict road hierarchy. Heavy industrial traffic was diverted onto specialized heavy-load arteries, shown in red. Residential commutes were isolated on thinner parallel routes, keeping the two entirely separate. Königsberger also applied band town planning. He organized the city into parallel strips. The industrial zones sat in one band, and the residential zones stretched out in an adjacent band. This kept commute times incredibly short, while minimizing the workforce's daily exposure to exhaust and pollution. By continually reacting to demand shocks with iterative, intelligent master planning, Jamshedpur absorbed geopolitical chaos without sacrificing its core function. The city survived the pressures of 2 global wars by ensuring the living standards of its people scaled right alongside the output of its furnaces. Today, Jamshedpur operates unlike almost any other municipality. It is a massive urban center managed entirely by a private corporate entity known as JUSCO, a Tata Steel subsidiary, rather than a standard government body. Despite housing one of the heaviest industrial operations on the planet, the city maintains 33% green cover. The civic metrics for water quality, for reliable electricity, and waste management consistently outperform most conventional government-run cities in the country. The plant itself functions like a massive industrial ship of Theseus. Unlike many historic factories that are eventually abandoned or relocated to cheaper land, the Jamshedpur Works has remained on the exact same patch of earth since 1908. It doesn't move, it simply rebuilds itself from the inside out. The most striking example of this is the E-blast furnace. This specific vertical vessel was commissioned in 1919 and has been burning molten iron continuously for over a century. Rather than retiring the E-blast furnace as a museum piece, Tata engineers use it as their primary testing ground. It stands as a physical proof of concept for the company's philosophy. You achieve longevity through relentless, unbroken modernization. Now, the global steel industry faces an existential crisis. The traditional method of smelting iron ore requires burning massive quantities of coking coal, producing immense volumes of CO2 that drive global climate change. This cross-section of the E-blast furnace shows exactly how they are addressing the problem. In 2023, engineers retrofitted this century-old structure to run a groundbreaking trial, continuously injecting large volumes of hydrogen gas directly into the molten core to replace the traditional coke fuel. The chemistry of this substitution is highly efficient. When you burn coke, the byproduct is heavy CO2, but when hydrogen reacts with the iron ore, the exhaust at the top of the furnace only releases water vapor. It yields the exact same industrial steel, but slashes the carbon emissions. Tata recently committed $1.22 billion to deploy advanced electric-assisted smelting and Hizarna technologies in Jamshedpur. They are actively re-engineering the oldest furnaces on the site to hit a net-zero emissions target by 2045. Back in 1867, the philosopher Thomas Carlyle stated that the nation capable of subduing iron would soon subdue gold. Jamshedpur Tata used that exact logic to break India's reliance on the British Empire. Jamshedpur proves that industrial dominance depends on a symbiotic balance. To survive a century of war and economic shifts, a facility must pair relentless technological upgrades with an unyielding respect for the people who make it run.